Welcome back to the CAIA Coder series. In our previous videos, we showed how Coder can build a complete application from a single intent, deploy it to Kubernetes on Google Cloud, and even organize over 1,000 files automatically using AI. If you haven't watched those videos yet, you'll find the links in the description below. Today, we're taking it a step further by demonstrating how CAIA Coder can autonomously investigate a failed GitHub Actions workflow, identify the root cause, fix the issue, raise a pull request, and generate engineering documentation, all with minimal human intervention. Let's get started. Let's look at another advanced workflow powered by CAIA Coder. In this example, we're solving a production issue inside a GitHub Actions workflow. We provide the workflow run URL and ask the agent to identify the reason for failure. We also ask it to fix the issue, raise a pull request, and document everything inside a Markdown file. Since this workflow involves GitHub Actions, we first add GitHub Context from the marketplace. This helps the agent understand repositories, workflows, and available actions automatically. We also want the agent to generate Confluence documentation. So before starting your existing script execution, we add the Confluence context as well. Before running the workflow, let's verify whether all required credentials are configured properly. From the settings section in the bottom left corner, we open the Vault configuration. Here we can see that GitHub URL and token are already configured. We can also see that Confluence URL, email, and API token are configured as well. Now everything is ready and we can start the process. Once we click on Send, the agent begins processing the request. On the right side, the execution logs start updating in real time. The agent first connects with GitHub and retrieves the failed workflow execution logs. It then starts analyzing the pipeline automatically. Without manual guidance, the agent understands what the workflow is doing internally. It identifies build processes, deployment stages, Helm chart updates, and Kubernetes operations. The logs also show each process involved inside the deployment pipeline. As the analysis continues, the agent identifies the root cause of failure. It detects that the Kaneko deployment job failed during execution. A few moments ago, we looked at the Vault section inside CAIA Coder, where all the credentials required for enterprise integrations are securely configured. Now let's understand why this is one of the platform's most important features. CAIA Coder is built around a zero-trust security architecture with a local encrypted credential vault. Unlike many AI coding tools that send credentials through cloud connectors or store them on external infrastructure, CAIA Coder keeps your GitHub tokens, Kubernetes credentials, cloud service accounts, SAP connections, Confluence credentials, API keys, and other enterprise secrets securely stored on your own machine. The AI agent never permanently stores or learns these credentials. Instead, whenever an authenticated operation is required, CAIA Coder securely retrieves only the necessary credential from the local vault, performs the requested action, and immediately releases access. This allows the agent to deploy applications, access enterprise systems, interact with cloud platforms, and automate complex DevOps workflows while keeping your credentials completely under your control. The result is enterprise-grade AI automation that follows zero-trust principles, making CAIA Coder suitable for organizations where security, governance, and compliance are critical. During the workflow, one GitHub operation fails because of an authorization issue. Instead of stopping, CAIA Coder automatically rectifies the authentication flow. Once connectivity is restored, the agent continues execution automatically. The agent now creates a new branch for the required fixes. It updates the deployment configuration and modifies the values YAML file. This ensures that future deployment processes remain stable and seamless. The workflow also showcases intelligent retry handling and adaptive execution behavior. Instead of requiring manual intervention, the agent corrects issues on its own. This significantly reduces debugging time and operational effort for engineering teams. The agent also fixes the Kaneko cache flag issue that caused the workflow failure. After applying the changes, the updated code is validated automatically. The agent then pushes the fixes and prepares the pull request workflow. At the same time, it starts generating RCA and troubleshooting documentation. The documentation is generated in Markdown format for easy sharing and review. The agent also attempts to publish the same documentation into Confluence. However, due to a connectivity or configuration issue, the Confluence operation fails. Even then, CAIA Coder does not stop the workflow. It intelligently completes the remaining tasks and preserves the generated documentation locally. This demonstrates how CAIA Coder handles failures during execution autonomously. It can analyze pipelines, identify root causes, apply fixes, and generate documentation automatically. From workflow analysis to pull request creation, everything is handled using AI. The agent traverses the complete deployment pipeline to fully understand the issue. It then applies the required corrections while keeping the workflow operational. This is how autonomous AI workflows can simplify DevOps and incident management processes. Now let's complete the documentation workflow. From the Project Explorer on the left, we drag the RCA_Carnico_error.md file into the chat section. Next, from the Marketplace, we select the Confluence plugin and add it into the context. This gives the agent the required context and permissions for Confluence operations. We then enter a query, asking the agent to create a Confluence document under the required space. Once we click Send, the agent begins processing the Markdown document automatically. It converts the RCA Markdown into a properly structured Confluence page format. Now let's verify the results directly inside Confluence. We navigate to the Confluence page in Chrome and refresh the space. As we can see, the complete root cause analysis document has been successfully created. The document includes the issue summary, workflow analysis, fixes applied, and troubleshooting details. This demonstrates how CAIA Coder can automate both engineering workflows and documentation processes end to end. That's the power of autonomous AI workflows with CAIA Coder. And this is just one example of how CAIA Coder goes beyond traditional AI coding assistance. From application development and Kubernetes deployments to GitHub Actions troubleshooting, automated pull request generation, enterprise documentation, SAP workflows, and infrastructure automation, CAIA Coder brings your entire engineering workflow into a single autonomous workspace. If you found this video helpful, please give it a thumbs up, subscribe to the channel, and share it with your team or anyone working in DevOps, platform engineering, or enterprise software development. Be sure to check out our previous videos where we built a complete application from an intent, deployed it to Kubernetes on Google Cloud, and automated the organization of more than 1,200 files using AI. You'll find links to all of them in the description below. Download CAIA Coder, start your free trial, and experience autonomous engineering for yourself. Thanks for watching, and I'll see you in the next video.